So in today's lesson we are going to be looking at special lines in a triangle again, and just as a recap of what we've covered so far, we have spoke about medians. So lesson 7 was on medians. You see the link there takes you to the YouTube video. It'll talk you through that if you need a refresher. And the diagram there shows you what a median is. So BM being a median, it comes from a point on the triangle to the midpoint on the opposite side. So it cuts through the middle, the midpoint of AC, and it comes from B. So that's what median. We then went on to discuss altitudes. Again, the link there to the video takes you to altitudes. BD is an altitude, so the altitude here comes from the point B, corner of the triangle, the vertex, and passes through the line AC at a right angle, perpendicular to it. It's not the midpoint, it is at a right angle. So you need to find the gradient of AC and work out the gradient of BD from that. And today we're going into the third and final type of special line. It's something called a perpendicular bisector, and it's a bit of a combination of both medians and altitudes. So a perpendicular bisector then is a line that cuts through the midpoint of a line segment at right angles. So you can see where the combination of the median, where it's a midpoint, and the altitude, where it's a right angle, are combined. So you've got a line that cuts another one in half. Special consideration there, if you look at these two diagrams, now sometimes the question will involve a triangle, quite often it will. However, sometimes I'll talk about a perpendicular bisector when it isn't in a triangle or it's some other type of situation. But you'll get used to these types of situations that you come across the more you do some practice. So in these diagrams, CD is a perpendicular bisector of AB. So the left hand side, you see that isn't a triangle, and it cuts AB in half and is at a right angle to AB. And the right hand diagram is in a triangle. It cuts AB in half and passes a gradient which is perpendicular, it has a gradient perpendicular to AB. And again, special attention to be paid there. The other two examples, the medians and the altitude, pass through a corner or vertex in your triangle. Perpendicular bisector does not usually do that. It can, okay, in special situations, but won't usually. So it's worth remembering that. Steps then to find the equation of a perpendicular bisector. It's an equation of a line, so it's going to be y minus b is m times x minus a. You need to find the point which is midway along AB, so it's using your midpoint formula, and you need to find the gradient of the perpendicular bisector, which of course when you multiply the gradient AB and the perpendicular bisector will give you -1. And just like the other two examples, the special types of lines, for a perpendicular bisector, when the three of them intersect, when they cross over inside the triangle, they meet at a single point which is called the circumcenter. So just a wee bit extra knowledge there, and some terminology for you. Perpendicular bisectors then. Remember, you've got a copy of all these notes when we return to school, so you don't need to worry too much about copying it down. Here is an example of the type of equation that you would get. So A is the point -2,1 and B is the point 4,7. Find the equation of the perpendicular bisector of AB. So you've got a line AB that's what it would look like. Or if you had to use the points A minus 2, 1 and B 4, 7, you could roughly put it in an X and a Y axis, and it would be a sloping line. It's similar to the one on the right hand side here, and the perpendicular bisector would be on a slope as well, which would be 90 degrees to AB. So the steps to find the equation of this perpendicular bisector: first thing we need to do is look at where the midpoint of AB is. The midpoint AB is this dot here where M is, this point where M is. The midpoint is halfway between minus 2, 1 and 4, 7. So the midpoint formula says you have to add your x's together, divide it by 2, add your y coordinates together and divide it by 2, and that gives you your midpoint. So when we do that, you've got minus 2 plus 4, which is 2, divide that by 2 gives you 1, and for your y coordinate is 1 plus 7, you divide that by 2 and that gives you 4. So you've already got a point now. You now need to think, well, what is the gradient going to be of the perpendicular bisector? So to do that, we can find the gradient of AB using the formula you've used a number of times now: y2 minus y1 and x2 minus x1. The points A minus 2, 1 and B 4, 7. Putting them into your formula, so you get 7 minus 1 on the top, 4 minus minus 2 on the bottom. So leaving you with 6 over 6, which at the level you're working at you would rewrite as being 1. So if the gradient of AB is 1, the perpendicular bisector would have to be minus 1, since 1 times minus 1 gives you minus 1. So you've now got a gradient and a point. The point is the midpoint. You found 1, 4. The gradient of the perpendicular bisector is minus 1. You're then at this point where you can put it into y minus b equals m times x minus a. Substituting in to get y minus 4 equals minus 1 bracket x minus 1. Then expanding out and tidying it up. So you get y minus 4 equals minus x plus 1. And if you add 4 on each side, you get y equals minus x plus 5. These 3 steps are the steps you use each time you're getting a perpendicular bisector. They're very similar to what you've been doing with the median and the altitude already. It's really important that you set out the working and explain what you're doing as you go through. It's especially important because you want to pick up as many marks as possible.